Good morning students. Today we are going to see about how PGP works. I am Dr.R.Suganya, Department of Computer Science with Cybersecurity. So PGP, which is pretty good privacy, is an encryption system used for both sending encrypted emails and encrypting sensitive files. Since its invention back in 1991, PGP has become the de facto standard for email security. Pretty good privacy is widely used to secure the email. So it is developed by Phil Zimmermann. It is selected and best available crypto algorithms to use integrated into a single program on Unix, PC, Macintosh and other system. It is originally free and now it is also have commercial versions available. PGP operations, which is authentication. Its sender creates message, make SHA-1160 bit hash of message. It is attached RSA sign, which is hash to message. The receiver decrypts and recovers the hash code. The receiver verifies the received message with hash functions. So this is what the PGP operations. So these 5 operation is an authentication operation. So next is confidentiality operation of PGP. The sender forms like 128-bit random session key, and then it encrypts a message with session key. It attaches a session key encrypted with RSA, and the receiver decrypts and recovers the session key. The session key is used to decrypt the message. So this is what about the confidentiality of the PGP operation. Now confidentiality as well as authentication operation of PGP, which can use both services on the same messages. So it creates a signature and it attaches to the message, encrypts both message and the signature also. So attach RSA and encrypted session key. So next is about the compression. By default, the PGP compresses the message after signing but before encrypting. So it can store uncompressed message and signature for later verification, because compression is non-deterministic. It uses zip compression algorithm. Next is about email compatibility. So when using PGP, it will have binary data to send. However, email was designed only for text. Hence, PGP must encode raw binary data into printable ASCII characters. It uses radix64 algorithm. It maps 3 bytes to 4 printable characters. It also appends a CRC. The PGP also segments messages if too big. PGP operation. So here we can say the file as X, and whether the signature is required or not. If it is yes, so it has to generate the signature and then it has to compress, and then the confidentiality is required. So if it is yes, then we have to encrypt that particular message, and then it has been converted to radix. This is a generic transmission diagram. Next is about generic reception diagram. So here we can have like conversion from radix. So how like encryption and decryption, the same way it takes place here. We are going to again we are going to take up the radix message, then whether it needs a confidentiality, and we are going to decrypt that particular message, and then we are decompressing. There we have compressing and here we are decompressing, and then the signature is required. Then if it is yes, then strip signature, and then we are verifying that particular signature. So this is what about the generic transmission diagram and generic reception diagram. Next is about PGP session keys. It needs a session key for each message of varying sizes like 56-bit, 128-bit and 168 bits. So 128 means it is IDEA, 56-bit means DES, and bit triple, it is bit triple means DES. So it is generated using ANSI X 12.17 mode. It uses random inputs taken from previous users and from keystroke time of user. PGP public and private keys. Since many public or private keys may be in use, need to identify which is actually used to encrypt session key in a message. It could send full public key with every message, but this is inefficient. Rather, it uses a key identifier based on key. It is least significant 64 bits of the key. It will be very likely be unique. This also uses key ID in signatures. PGP message format. Here we can see the session key component, signature and message. So key ID of recipient's public key, and then timestamp, the file name and the data. So this is the message format. So how the PGP works in the format like message, signature and session key component. So we have variables used for each and every things like message. We have timestamp, for file name, the keys, session keys, all that, key ID, and PGP key rings. Each PGP user has a pair of key rings. So it contains all the public keys of other PGP users known to this user, indexed by key ID. And the private key ring user contains a public or private key pair for this user, indexed by key ID and encrypted keyed from a hashed passphrase. Security of private keys thus depends on the passphrase security. So here we have like private key ring, the timestamp, key ID, public key and encrypted private key and user ID. So here the PGP message generation. So how the PGP works and operates and how the message is being generated. So it's a passphrase, then it starts from and private key ring, how it has been encrypted with the private key which has the key ID, and again how the message is being encrypted with the session key, and if it is a digital signature, how it has to use and how we are getting the output for particular operations. So here we have the PGP key management. So rather than relying on certificate authorities in PGP, every user has own CA. It can sign keys for users they know directly. It forms a web of trust. Trust keys have signed. Can trust keys other have signed if have a chain of signatures to them. Keyring includes trust indicators. Users can also revoke their keys. Trust model example we have. So here we have like variables, and like from A to E, F, G, H to Q, R, S. Okay, so here we have the nodes. So how it is, X is being signed by Y, and so here it is being denoted with each and every nodes. So the shaded part of the circle contains a keys owner which is trusted to the signed keys, and the second which is partial trusted by signed keys, and we have deemed legitimate. Summary: it have considered as secure email, so as it is a PGP operation. Thank you.